Hello, here we are in section 3.1, and that's called Measures of Central Tendency, which is a fancy sounding phrase for the idea of ways to measure where the middle of some numbers are. And the first idea we've got here is one of the arithmetic mean, which you might know by another term, which is just the mean. And they talk about how you compute it by adding all the values and dividing by the number of observations. And they're putting this in the context of data, but really what this is just the average of something. It's the mean, the average. They're the same thing. And so how do we find that? We add up all the values and we divide by the number of observations. So for example, let's find the mean of these four numbers. So we're going to add them all up and then divide by the total number of observations, which in this case we have four numbers. So that gives us 22 over 4. And if I want that as a decimal, that's going to be 5.5. So you would call 5.5 the mean of these four numbers here. So we've mentioned before in statistics there is a distinction between the population and the sample. The population being the large group of individuals we're interested in, and the sample being a subset of that large group. With the average or the mean, we're going to be interested in the mean of both of these groups. Sometimes we're going to be talking about the mean of everything we're interested in, and sometimes we're only going to be talking about the mean of this small group known as the sample. And let's start out by talking about the sample mean. The symbol for the mean of our sample is this X with a bar over it, which very cleverly we call X bar. And we find that by taking the sample and finding the average of whatever variable we're dealing with from the sample. And we call that X bar, and that is a statistic. That is a numerical measure of the sample. Here's an example. Suppose we're interested in the GPA of every single student at Community College of Denver. So our population here is all the students at Community College of Denver, which is a lot of students. That's over 10,000. It might be hard to find information on all of them, so we might take a sample and find the mean of that sample. Suppose that we sampled 10 students and found that their average GPA was 3.1. So this 3.1 came from taking 10 grade point averages from 10 students, adding up all those grade point averages and dividing by 10. So since this is a number that describes our sample, then this number here is X bar. And furthermore, this number is a statistic. Anytime we have a number that's describing our sample, that number is a statistic. So in addition to calculating the sample mean, sometimes we'll be concerned about what is the mean of the entire population, the entire group that we're interested in. And it's still an average, it's still a mean, but it's not just the mean of that small group, it's the mean of the entire larger population. And when we're dealing with the population mean, we don't use X bar anymore. We use this symbol that looks like an M and a U together. It's pronounced mu, kind of like M and U. It's actually a Greek letter, and you write it like this, where you're just kind of writing a cursive U. This is mu, and this is the mean of all the values for a particular variable in our population. So sometimes this might be dealing with a very large number of individuals, and this number frequently, this population mean, is hard to know. And like we mentioned before, that's true of parameters. Parameters are numbers that describe the population. Mu is a number that describes the population, and parameters tend to be unknown because they're describing a large group of individuals. So before we talked about this situation where we were interested in the GPA of all students at CCD, and we said that the mean of our small group of students would be called the sample mean, and that's X bar. The mean of our sample is X bar, and that's a statistic. But what about the mean of all of our population, the mean GPA of every single student at CCD? That would be what we call the population mean here. So we could describe that. That's mu, and that is the average GPA of every student at CCD. And that is a parameter. And that is going to be harder to know because that involves finding the average GPA of every single student at CCD, adding up all those GPAs and dividing by the number of students. And it's true that in this case, probably the school has data on what everybody's GPA is, and the school can probably do that. But you could imagine maybe if you were doing a research project for some class and you wanted to try to figure out what the average GPA of every single student is at CCD, you wouldn't have access to that information. You wouldn't know this parameter, which is why we say parameters tend to be a little more mysterious than statistics. Parameters tend to be unknown. Let's just recap here. We said the mean of our population is going to be mu, and the mean of our sample is going to be x bar. That is the sample mean. These are both numbers. Mu and x bar are both numbers, but one describes the sample and one describes the population. One is typically known, that would be x bar. Not just typically, you can always find the mean of your sample. But the population mean a lot of times is going to be unknown because that involves so many individuals.